So this is further statistic 1 at Excel, the second chapter, Poisson distribution with the flag EMP. So the number 1, stretch of load accident occurs at per month. So this is, we can say X is following the distribute of Poisson distribution lambda 0.7, but usually I just write it down, the unit here. And number A, so no accident in the next month. This is the probability. X is a smaller, X equals 0. I will calculate it, and probably exactly 2 accident. So X becomes 2. No, so this is not like this. So because now it changed the duration, like 3 months. So now Y is following the 2.1. So probability Y becomes 2. And number C, no accident in exactly 2 of the next 6 months. Exactly 2 of the next 6 months. So again, W becomes 6 months. So W is following Poisson 4.2. But now we have 2 6 months. So probability W becomes 0, but squared. So let's find those numbers from the. So let's see the table. This is the formula booklet of the further math, and we have the table for Poisson cumulative distribution function. So when x equals 0 with mean 0.7, we don't have here. But now we have instead of the Poisson, we can calculate e to the power of 0.7 times 0.7 to the power of 0 and 0 factorial. So e to the power of negative 0.7. So this is 0.497. And this one, when x equals 2, e to the power of negative 2.1 times 2.1 to the power of 2 and 2 factorial. So e to the power of negative 2.1 times 2.1 squared over 2. So 0.270. So now this is the one, like e to the power of negative 4.2 times 4.2 to the power of 0 and 0 factorial squared. So e to the power of negative 8.4. So this is 0.000225. And let's go to the number 3. Now we have y equals 5 is 1.25 times the value of y equals 3. So P y equals 5 is 1.25 times of P y equals 3. So now we don't know what is the lambda. So e to the power of negative lambda and lambda to the power of 5 and 5 factorial becomes 1.25 is 5 over 4 and e to the power of negative lambda and lambda to the power of 3 and 3 factorial. In this case, it's better to cancel out this one, and it's very reasonable to do that because e to the power of negative lambda cannot be 0. We can cancel out when we are assured that it is not 0. So we can cancel them out. So lambda to the power of 5, 120 minus 5 lambda to the power of 3, 24. which means 25 and 120 equals 0. So 120 lambda to the power 3, lambda squared minus 25 becomes 0. Therefore, lambda is 5. And number 6, number of telephone calls per hour, small business, lambda is an integer. So when y is larger than 10 means 1 minus probability y is smaller or equal to 9. No, actually 10. Because larger than 10 means from 11. So we need to remove until 10. So this is smaller than 0.1. So 0.9 p y is smaller than 10. So now we can use the table here. So we will find the number which is larger than 0.9. So this is cumulative like this. X is smaller or equal to x, Poisson, and smaller than 10. So when x equals 10 here, so this should be larger than 0.9. Wow. So here we found 7 and 8. So probability when lambda is 7, 7.0, then probability y is smaller than 10 becomes 0.9015. When lambda equals 8.0, because it says it's integer, then equals 0.8159. So this happens from when lambda equals 8,0. So it says, I'm sorry, the largest possible value of lambda is 7. Because until 7, it is larger than 0.9. From 8, it's smaller than 0.9. Number 8. Angler known to catch fish 2 per hour. So lambda is 2, but it's per hour. So number of fish angler is an hour follows a Poisson distribution. 5 fishing trip, each lasting 2 hours. So this means now to lambda 4 per 2 hours. So find the probability angler catches at least 5 fish on exactly 3 of these trips. So now we have 2 hours, but we have 5 fishing trips. So now it becomes 2. So let's find the probability. Let's make it x follows the Poisson distribution, which is 4. And probability x is at least 5, like this, means 1 minus smaller or equal to 4. Then it goes to binomial distribution. So let's go to Poisson. This is normal. So now when lambda is 4, so here and 4, 0.6288, 1 minus 0.6288. So 1 minus 6288. 0.3712. So this is the probability. So we repeat this for 5 times, and we will make it exactly 3 of these trips. So now y follows binomial distribution, trial 5, number of trial is 5, and the success probability is 0.3712. So exactly 3 means probability y becomes 3. So 5 to 3 times 0.3712 to the power of 3 and 0.6288 to the power of 2. So let me calculate it. 5C3 times power of 3 times power of 2, 0.202. So number 9, number of cherries, fruit cake follows Poisson distribution, mean 2.5. So one cake has the average mean 2.5 cherries. Fruit cake is to be selected at random, counting exactly 4 cherries. So now X follows Poisson 2.5 and AI exactly 4, probability X is 4, and probability X at least 3 means 1 minus X is smaller than or equal to 2. So this 4 is e to the power of negative 4 times 4 to the power of I forgot. 4 to the power of 4. No, I mean 2.5. E to the power of 2.5. 2.5 power of 4 over 4 factorial. So negative 2.5 times 2.5 times over 4. So 0.134. And this is from the table 2.5. 2.5 is here. Smaller than 2 is 0.5438. Then 0.4562. And number B. Megan's fruit cake sold in pack of 4. So now we have 4 cakes. So more than 12 cherries in total. So now we need to find y, which is 4x 10. So probability of y is more than 12 means 1 minus y is smaller or equal to 11. And C, A packets of Megan's fruit cakes. So one packet has 4 cakes. So we still follow this y. So 8 packets, so which means maybe this follows binomial 8. Find the probability that exactly 2 packets contain more than 12. Okay, so now we need to calculate more than 12 first. So 10 and 11. Okay, so 10 and 11 here. 0.6968. 0.6968. So 1 minus 0.6968. 0.3032. 0.3032. So now what we want to know is exactly 2 packets. So W becomes a 2. So 8C2 and 0.3032 to the power of 2, 1 minus 0.3032, which is 0.6968 power over 6. Oh, just let me check what kind of table we have for this binomial. This is cumulative. So A to C. And 0.3032 squared to the power of 6, 0.295. And number 10, car salesman sells cars and mean rate of 6 per week. So lambda is a 6 but per week. Suggest a suitable model to represent the number of cars sold in randomly chosen week given two reasons to support your model. So the days of selling is independent and it doesn't happen at the same time. So that is the condition for the Poisson distribution. So now X follows the Poisson distribution of 6. And find the probability that in any randomly chosen week, the sales sells exactly 5 cars. So probability X equals 5. The power of negative 6. 6 to the power of 5 factorial. So number C, let me find it. Find the probability that in period of 4 consecutive weeks, exactly 2 weeks, in which the salesman sells exactly 5 cars. So I need to calculate it. So e to the power of negative 6 times 6 to the power of 5 over 120. So 0.161. So number C is follows binomial distribution 4 consecutive weeks, and the success is exactly 5, like this. So this is not like 24 Poisson distribution. I mean with the mean 24, because this is just checking each week. So it's binomial distribution. So probability W is exactly 2 weeks. So for C2, 0.161 to the power of 2, 1 minus 0.161 power of 2. You can calculate it. Number 11, Abby and Ben shares a flat. Mean rate of 1.2 letters per day. So Abby follows Poisson 1.2 per day. And B follows 0.8 per day. Assuming the letters are independent to calculate probability on particular day, each received at least 1 letter. Each receives. So probability A is at least 1 letter times, because now let's make it like this, and B like this, but they are independent, so we multiply them together, times probability B is larger than or equal to 1. So this is like 1 minus A equals 0, 1 minus B equals 0. So this is 1 minus 1 point e to the minus 1.2. Why I cannot memorize it? 1.2 to the power of 0, so 0 factorial. 1 minus e to the power of negative 0.8, 0.80, 0 factorial. So you will find the number when you use the calculator. Number B, total of a 3 letters. So now A plus B follows Poisson 2. So because the mean is just added them together. So probability A plus B is total 3 letters, like this. So 2 and 3. So now e to the power of negative 2 and 2 to the power of 3 over 3 factorial. When we count the calculated, you will find the answer. Given the post delivered to the flat from Monday to Friday. So now we have 5 days. Sounds like, again, this becomes to binomial distribution. So we need to calculate this one because we need to use it. Negative 2 times 8 over 6, 0.180. So number C, W follows binomial distribution with 5, 0.180. So now probability W and it's 3 of the days. So which means 1 minus probability W smaller than 2. So here, can we find it here? Cumulative binomial probability 1.180. 180. Yeah, this is difficult. Okay, so I need to calculate it from the calculator. So there is the distribution. I use the distribution function on my calculator. If you don't have, you can calculate W equals 0, W equals 1, W equals 2, and subtract. Now I'll make a binomial CDF. Number of trial 5 and success probability 0.180 and X value 2. Then the answer becomes 0.0437. Number 12. Electrical outlet says desktop and laptop computers. Desktops are sold at a mean rate of 2.4, laptop 1.6 per day, both. Enlist the 2 laptops. So from the desktop follows Poisson 2.4 per day, and laptop follows Poisson 1.6 per day. So probability, those are assuming they are independent, then at least 2 desktop and at least 2 laptop. So since I assume that they are independent, so times we can multiply them to find the intersection. So 1 minus probability 1 minus probability L smaller than or equal to 1. So you can calculate it. So now you will find 2.4 here. Oh, there's no 2.4. 1.6 we don't have. So we need to do probability 0 and 1. So 0, negative 2.4, 2.4 to the power of 0, 0 factorial, minus, like a plus, 2.4, 2.4 to the power of 1, 1 factorial, times 1 minus e to the power of negative 1.6, 1.60, 0 factorial, plus e to the power of negative 1.6 and 1.6 to the power of 1 and 1 factorial. So this is the number A. Combine the total of 6 computers. So D plus L follows Poisson 4. So probability D plus L, total 6. So e to the power of negative 4, 4 to the power of 6 over 6 factorial. over a 2-day period, they said a combined total of no more than 6 computers. Combined total of no more than 6 computers. So now this is per day, so over a 2-day period. So now we need to know 2d plus l, because now we have 2 days. So this is 8. So follows 2d plus l, combined 2 days, no more than 6. Like this, smaller or equal to, no more. So we can calculate this one. So we have 8 and 6. So now from the table, 0.3134. And number 13. Airline knows that over 4% of passengers do not turn up for flights. Ooh. Airline has policies of selling more this is not EMP. Number 16. Accident occur randomly roundabout at a rate of 15 every year. Fewer than 5 accidents, 6 months period. So this is per year. So which means lambda now 7.5 for the 6 months. So X follows Poisson distribution with 7.5 and probability fewer than 5 accident means probability X is smaller than or equal to 4. Because the Poisson is discrete, so when it is smaller than 5, it means smaller or equal to 4. So 7.5, do we have 7. Okay, 7.5 and smaller than 4, 0.1321. And there will be at least one accident in a single month. So let's call it M, Poisson, 15 over 12. This is the rate. Then probability, at least one accident. Like this means 1 minus probability m equals 0. So 1 minus e to the power of 15 over 12 times 15 over 12 to the power of 0, 0 factorial. So you can calculate it. And number C. Find the probability that there is at least one accident in exactly 4 months of a 6 months period. Okay, so now this is binomial. So now we have 6 months, and which means I need to calculate this one. So 1 minus e to the power of negative 15 over 12, 0.713. 450. Let's just make it more decimals. Then now this is binomial. So let me call it W. Binomial. 6 months. 0.71350. So exactly 4. W becomes 4. So out of 6, success is 4. Success means the expectation happens. So 4. 1 minus 0.71350 to the power of 2. This is the answer. Number 17. Office photocopier breaks down randomly 8 times per year. So A exactly 2 breaks down in the next month. So this is just 1 month. So X follows Poisson 8 over 12. So probability X becomes 2. And e to the power of 8 over 12. 8 over 12 power over the power of 2 and 2 factorial. And find the at least 2 breaks down in 3 of next 4 months. So n needs to break down in 3 of next 4 months. This is exactly to break down. So now we want to know n leads to 2. So n leads to 2 means 1 minus x becomes 0 and x becomes 1. So 1 minus e to the power of 8 over 12, 8 over 12, 0, 0 factorial, minus e to the power of 8 over 12, 8 over 12 power 1, 1 factorial. Then you will find the probability here. Let's call it p, let's say. Then next 4 months, w follows again binomial. Number of trial 4, and needs to break down p. So probability w becomes 3, and for C3, p to the power of 3, 1 minus p power of 1. That's it.